Unit 10 is a unit on trigonometry, and trigonometry is the study of triangles. At the top of the paper, we have a definition for trigonometry, and it talks about how the word trigonometry technically means angle measure. And when we are talking about a trigonometric ratio, it is going to be a comparison between two of the sides of the triangle. Three of those comparisons are the words sine, cosine, and tangent, which we can abbreviate as SIN for sine, COS for cosine, and TAN for tangent. So those are going to be very common abbreviations that we go through and use. With respect to those trig ratios, we will always be referencing a triangle's angle. So because we can see in each of these trig ratios that we're talking about angle A is going to be the angle that we're referencing in this particular triangle. You can see that with respect to angle A, side BC is the side opposite, side AC is the side adjacent, and the side that goes from A to B is the hypotenuse. The hypotenuse is always found across from the right angle. So technically there are two sides that are adjacent to angle A. This is the one that's called the adjacent side because this side, although it's next to angle A, is across from the right angle, so this side would be the hypotenuse. So if we fill in the relationships for the sine, cosine, and tangent, the definition of sine is the side opposite over the hypotenuse. So if I was writing this in symbols, I would put the sine of angle A equals opposite over hypotenuse. In this particular case, that would be side BC over side BA. The side opposite over the hypotenuse. For cosine, it's the adjacent side over the hypotenuse. Abbreviated, the cosine of angle A equals adjacent over hypotenuse, A over H, which would be side CA, the adjacent one, over the hypotenuse BA. Tangent is opposite over adjacent. So for this particular example, the tangent of angle A, opposite over adjacent, which would be side BC, the opposite one, over the adjacent. So you can see that if you're using these trig ratios, you can't really do too much if you haven't first identified where your angle is that's being referenced and where the particular sides are, the opposite side, the adjacent side, and the hypotenuse. So when we go ahead and we take a look at example number 1, it's telling me to find the sine, the cosine, and the tangent of the following angles. One of the ways that I remember sine, cosine, and tangent is by a mnemonic device called SOHCAHTOA. So in here, the sine, cosine, and tangent ratios are represented by opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, opposite over adjacent for tangent. So that little SOHCAHTOA helps me remember which ratio of the sides goes with which trig function. So if I am focusing on part A on angle P is right here, which means that this is the opposite side, this is the adjacent side, it's next to angle P, and then this is the hypotenuse that's over here. So when I go through to find the sine of angle P, I know, according to my mnemonic device, that sine is opposite over hypotenuse. Whoops. Opposite over hypotenuse, which is going to be 7 over 25 when I take the opposite and put it over the hypotenuse. For cosine of angle P, I know it's adjacent over hypotenuse, so 24 over 25. And then for the tangent of angle P, it's opposite over adjacent, which would be in this case 7 over 24. So in this example, they did give us the side lengths, which we could go through and substitute in, where we didn't have to do that in this upper example because we didn't know any of the side lengths. The only thing we could do was name the sides by their endpoints, BC, BA, and CA. With respect to example 1B, and now we're looking at angle N, we have to change our focus in this triangle to now looking at this angle N. And if the angle changes that we're focusing on, so do the names of the sides. So now with respect to angle N, this is the opposite, this is the adjacent, and this does stay the hypotenuse because it hasn't moved. It's still across from the right angle. So with respect to the sine of angle N, opposite over hypotenuse, 24 over 25. The cosine of angle N, 7 over 25. And then the tangent of angle N, which is opposite over adjacent, 24 over 7. So it might be the case that they just ask you to go through and find out the ratio where you're matching up the sides with the mnemonic device SOHCAHTOA. In question number 2, they want you to find the value of each of these to the nearest 10,000th. So that's going to be after the decimal place, the tenths, hundredths, thousandths, 10,000ths. So you want to round to the 4th decimal place. For this example, you're going to do this right on your calculator. So on my calculator, I'm going to type in the sine of 42. And when I do that, I can see the decimal value that I get. If you did not get the same decimal value that I did, there is a good chance that your mode is set wrong. So if you hit mode and you go down to the first, second, third line, you have an option on how you want to measure your angles. So there's radians and degrees. You want to make sure that the degrees are highlighted. If they're not, and in your case you have where the radians are highlighted, you want to arrow over, so degrees is flashing, hit enter, and it moves the highlighted section over to the word degree. It should be easy for you to remember which mode you're supposed to be in because you've only ever measured angles in degrees. You don't know anything about radians. So if you didn't already get the right answer, go back now and type in again that sine of 42 once your mode is changed, and you'll see that you get this answer. So we are rounding to the nearest 10,000th. In this case, even though we're rounding, the Regents expects that you write out the whole decimal. And that's something you're going to get very used to in this unit, and then you round from there. So I'm rounding to here. I look at the number after it. It's less than 5, so I'm going to keep this number as a 1. And then I'm going to go through and do the rest of the examples. So I'm going to type in the cosine of 65. So 0.4226, 182,617, rounded. 0.4226, this is what I'm rounding to. Tangent of 78, 4.7046, 30109. So this is 4.7046 for my final answer for that one. And then we're going to flip our paper over and do a couple of examples with trig. For questions 3, parts A, B, C, and D, they are giving us an example and asking us to find x. When we go through and we do these, we have to make sure that we can name the sides and determine the trig ratio. So our first step is to identify the angle that's being used, name the sides, and that's with opposite, adjacent, hypotenuse. And then step 3, set up the trig equation using that ratio that we know. So in my particular picture, the side that's across from 36 is the opposite because that's the angle we're using. This is the adjacent. This is the hypotenuse. In this particular case, the way I determine what it is that I'm using is based on the sides that are labeled. I know I'm using opposite because that's what I'm looking for, and hypotenuse because that's a side length I know. I am not using the adjacent side. So in this case, if I'm using opposite and hypotenuse, I go back to that mnemonic device, SOHCAHTOA, and I can see that if it's opposite and hypotenuse, I'm using sine. So the formula is the sine of the angle equals opposite over hypotenuse. So the sine of our angle, which is 36, equals x over 21. To solve this, sine 36 is a number. So if I have a number here, I'm going to put it over 1 and cross multiply. So I will get x equals 21 times the sine of 36. You always want to put the number in front of the trig function. From this point, I can type this into my calculator. So on my calculator, I'm going to type in 21 sine 36. And that is the answer that I get. Even though the directions do say to round to the nearest hundredth, I have to write the whole decimal down before I round. So my answer for x is 12.3434903. Rounded to the nearest tenth is going to be 12.3 for my final answer. For question C, I'm going to do this one with you. I'm going to move the x value though. So I'm going to move the x value to here. When I go through and I solve this equation, I have to pay attention to the angle that they're referencing. With respect to that angle, this is the adjacent side and this is the hypotenuse. So if I go back to the SOHCAHTOA and I pay attention to the sides that I'm using, which is adjacent and hypotenuse, notice nothing is happening with the opposite side. That's going to put me at cosine. So the cosine of the angle is adjacent over hypotenuse. So cosine of 21 is x over 73. I'm going to treat this like a number because it is. Cross multiply, so I have 73 times the cosine of 21. Always put the number that you're multiplying by the trig function in front, so the 73 goes in front of the word cosine. Type this into my calculator. I'm typing in 73 times the cosine of 21, and I end up with that answer. Again, the Regents rules are that you must write down that whole ugly decimal before you round. And again, in this case, we're rounding to the nearest tenth. Part B and D, I'm going to have you work on your own, and I may come back at the end and do another video where you can check your work. For question number 4, it's a word problem example. So the state does like to put some of these kind of examples in here. It's talking about the Leaning Tower of Pisa, which is not perpendicular to the ground. It says it tilts at about a 5.2 degree angle from the vertical. So that's going to be the angle that's over in here. It's kind of hard to see in this picture, but the angle that's here. It says it's 55 meters tall, and they want to know how far its top part has shifted. So I'm going to kind of draw that triangle that they've outlined for you separately here so we can really see what's going on. Here's B, C, and A is the 5.2 degree angle. 55, and they want to know this. So if I'm working on this particular question, the angle being referenced is 5.2. This is the side opposite, this is the adjacent, this is the hypotenuse. I'm not doing anything at all right now with this hypotenuse, but I am using opposite and adjacent, which, if I use the SOHCAHTOA, opposite and adjacent is here, which tells me I'm using tangent. So it's the tangent of the angle equals opposite over adjacent. The tangent of 5.2 equals x over 55, and then I'm going to cross multiply and solve. So this is 55 times the tangent of 5.2. Type that into my calculator. And in this particular question, they're telling me to round to 4 decimal places. So 5.0054. This is where I'm rounding to. The 9 bumps that one up. If it doesn't say to round it all in your question, you should not be rounding, and you're going to see that on your homework. So sometimes you do not need to round. Question 5 I'm going to leave for you to work on your own. Come back and check your answers on a second video. Question 6 we'll do together. It says a cable anchors a utility pole. So this is the utility pole, and this is the cable that comes down and anchors it to the ground so it doesn't fall over. The cable forms a 70-degree angle with the ground. The distance from the base of the pole to the anchor point is 3.8 meters. They want to know how long to the nearest meter the support cable is, so this is what I'm looking for. With respect to the angle of 70 degrees, this is adjacent, this is hypotenuse, so I'm going to be using cosine. So cosine of the angle equals adjacent over hypotenuse. Plug in the information. Cosine of 70 equals adjacent of 3.8 over x. So in this case, the x is now on the bottom. We're going to still have the same process. We're going to cross multiply. Remember, cosine 70 is a number. When I cross multiply, I have x times the cosine of 70 equals 3.8. I'm going to divide both sides by the cosine of 70 to get x alone. Cosine 70 is a number. And then on my calculator, I'm going to type in the 3.8 divided by the cosine of 70, which gives me a value, unrounded, of 11.11045672. To the nearest meter is 11 meters. So I'm rounding that to the nearest meter. Question 7 comes right out of the Common Core binder. There's a little bit of reading involved in this, which is fairly typical for the Common Core, so I want to make sure that I know what's going on. I'm going to draw a very detailed picture with everything labeled. 3 city streets form a right angle. So I am going to, in here, draw my 3 city streets. Main Street and State Street are perpendicular, so I'm going to name these. So here's Main and here's State that meet at that right angle. Laura and State meet to form a 50-degree angle. So where Laura and State meet is a 50-degree angle. The distance along Laura Street to Main is 0.8 miles. So the distance along Laura going to Main is 0.8. It says that in this particular scenario, Laura Street is closed. And it's closed between State and Main. So basically, we're not allowed to travel along this stretch of the road. They want to know how far to the nearest 10th someone would have to travel to go around the festival that's occurring here if they have to take Main and State Street. So technically, I need to figure out how far it is along Main Street to State and then along State back to Laura. So I'm basically being asked to find 2 measurements here. With respect to the angle that is being referenced, which is right here, this is the side opposite, this is the adjacent, and this is the hypotenuse. I'm going to first start working with the x, so I'm not going to work on this side of y here. And with respect to x, it's opposite and hypotenuse, so sine. So sine of the angle equals opposite over hypotenuse. The sine of 50, the angle being referenced, equals x over 0.8. So when I cross multiply now and solve, I get x is equal to 0.8 sine 50. put that into my calculator. And that's the distance along Main, the x value. Even though it says it's how far to the nearest tenth, you never round until your very last step, so I'm going to put a note here, round in your very last step. And then I'm going to go through now and find the y value. So with respect to the y, I'm not working with x now. With respect to this angle, I have side of y adjacent, side of 0.8 hypotenuse. Adjacent and hypotenuse is cosine, so the cosine of the angle equals adjacent over hypotenuse. That is then the cosine of 50 equals y over 0.8. Cross multiply. Y equals 0.8 cosine of 50. And I type that into my calculator. I come back with an answer of 0.51423000877. Remember, we're avoiding the festival, so my now total distance is going to be what I got when I took the x plus the y. In this case, that will be 0.61283555545 plus what I got for y, and I need to add them up. Which gives me 1.127065642 to the nearest tenth, 1.1 miles. So the distance that they need to travel to go around the festival is 1.1 miles. There will be a second video posted with the missing questions done. Please go through, practice those couple of questions, and check your work.